Now, let's look at the second approach of doing hypothesis testing. The step 1 and step 2, just like those steps in the first approach. Step 1, we set up the hypothesis. Again, H0, the null hypothesis, is pi equal to 50%. Against HA, we pick up pi not equal to what? 50%. Two-sided alternative. This is what we pick up in the first approach. So we still use the same alternative in second approach. Okay, so you can see the difference. Now, second one, step 2. We choose alpha equal to 5%. Well, the level of significance still 5%, just like the first approach. The difference begins with what? Step 3. We use a different test statistics. Okay, we use a different test statistic. In this approach, the test statistic used is no longer X bar. We use what? We use Z. But how this Z is obtained? It is obtained by standardized X bar. Okay, by subtracting its mean and divided by its what? Standard deviation. Or I say X bar minus by EV X bar and divided by what? SE X bar. And that is Z-score. And this is the reason why you get what? The Z-score. And we use Z as what? Test statistic in this approach. So the decision, reject if Z is too big or Z is too small. It's actually, remember in the first approach, we reject H0 if X bar is too big or X bar is too small. So if you standardize it, it becomes what? If Z is too big or Z is too small. Okay? So how big you call too big, how small you call too small. Let's look at the picture. Okay? Now look at the picture. This is standard normal curve. Okay? From here to here, cover 95%. And we choose alpha equal to 5%. So upper tail cover 2.5%. Lower tail cover what? Minus 2.5%. If you check the standard normal table, you find these two numbers. These two what? Z-score. One is 1.96, the other one is minus 1.96. So I'm going to rewrite the decision as reject H0. Okay? I'm going to rewrite the decision as reject H0 if Z is too big, Z is greater or equal to 1.96, or if Z score is too small, Z less or equal to what? Minus 1.96. Okay? Next, let's look at step 4. Let's look at step 4. Now, the observed X bar, the observed sample percentage, is 40 out of 100. Okay, and that is 0.4, 40%. And what is observed Z-score? Well, observed Z-score is obtained by standardized what? X bar. So X bar minus EV X bar over SE X bar. Or you can say this is X bar minus what? Average of the box divided by standard deviation of the box over square root n. Okay? Now, or I can write this one as X bar minus mean, the population mean, over what? Population standard deviation sigma divided by square root of sample size. Okay? And that is, if I convert to what? Convert to count box. Okay? X bar minus pi over what? Square root of pi times 1 minus pi over n. Okay? This is population percentage, and pi times 1 minus pi takes square root. This is what? This is population standard deviation. Okay? Now, under H0 is true. Under H0 is true. under H0 is true, pi is a fair coin. Pi is equal to 50%. Plug in 50% here, 50% here, 50% here, and divided by sample size of 100. So it becomes x bar minus 1/2 over square root 1/2 times 1/2 divided by sample size 100. So this is x bar minus 1/2 over 1 over 20. And that is, well, the observed x bar we can plug in now, okay? The observed sample percentage is, when we flip the coin 100 times, we see 40 heads. So it's 0.4. We plug in 0.4 here. Okay? So the observed what? The observed z-score is -2. Okay? The observed z-score is -2. Now let's look at the chart. Let's look at the chart. Now, minus 1.96 and 1.96 are the critical z values. Okay, they are the critical z values. They are the critical z values. Or you just say then what? You just call them, or you just call them critical values. And the shady area is a region of rejection. Okay, this is a region of rejection. And some book call from here to here, from minus 1.96 to 1.96, the region of acceptance. Okay, so compared to this one, this is a region of rejection. And we find our observed z-score minus 0.2.00. It falls in what? In the region of rejection. Okay, it falls in the region of rejection. So what is our conclusion? So our conclusion is, since -2 is less than minus what? 1.96. Okay? So we reject H0 because the observed value fall inside the region of rejection. So our conclusion, reject H0, the difference is real. When I say the difference is real, means that the reason why you see there is a difference between what you expect and what you observe is simply because what? It's simply because you believe the coin is not a fair coin. That's why you see the difference. And this is the second approach, okay? This is the second approach.